data is everywhere. We are completely surrounded by data, and in order to process any information in our brains or in our devices or computer systems, we need to process and deal with lot of data. Now, you must be thinking that, hey, I don't see any data around me. Well, I see it. Let me give you an explanation. Data is nothing but a way to represent any particular situation, scenario, or information. Now, if I'm trying to explain you that what city I belong to, I can say things like I live in city called Toronto. Then city is located in the southern part of Ontario. It is in Canada. Maybe like close to 6 million people live in the city. It is 10,000 kilometers wide or something. All of these things are actually data points that represents the reality of city called Toronto. And that's how we relay information, that's how we communicate, and that's how we think. Same way we need data for our computer systems to work efficiently as well. So in this video, we are going to talk about that how we can store, manage, and maintain data in our computer system. What are the different mechanisms to us? And then we are going to put more emphasis on two data types. Number one is SQL databases, and number two is NoSQL databases. Both are super important and super critical. You need to know under which scenario, what type of database you are going to choose. Now, I'm going to be honest. I'm going to go as if you are a beginner. So I'm going to explain in a very detailed manner about what SQL databases are, what are NoSQL databases, what are the differences, and under which scenario, which one to choose. I'm going to timestamp each one of them. And if you already know what is SQL and what is NoSQL and you just want to know the difference, go to the very end of the video in the last section, because this is going to be a long video. So without any delay, let's get started. So first, let's try to understand that what are the different types of data we typically have to deal with in the computer system. So number one is structured data. Now think of this structured data as like a data that can be fit in typical common tables where you can have nice values representing rows and columns. Like if I have to decide what type of person is there, I can create a person table basically, and where I can have information about first name, last name, date of birth. Second one is semi-structured data. Now this is the data typically systems deal with in terms of storing different values, different transactional data like JSON, XML files, logs, and stuff like that. This is really important for many reasons. And last one is unstructured data. Now it was not so popular maybe 20-30 years back because we did not have mechanisms to store audio, video, and images in the computer system. But now this is one of the majority of our data storage content, because with the rise of mobile phones and companies like Netflix and Amazon Prime, we have tons and tons of unstructured data that we have to take care of in a very fast and efficient manner. So after learning what are the types of data available to us, now let's see that what is database. Database is nothing but a simple mechanism to store large volumes of data that you can create, remove, or do all sorts of things in an efficient and scalable manner. Now databases would allow you to do all the common operations on a data. Just I mentioned, like you can add, modify, delete, process, and whatnot. The thing is, incoming data source can be anything, and database should be able to provide us with the connectors or a mechanism to connect to the database with which we can do all of these operations. On top of it, any person, software, machine, application can be able to connect to the database and complete the fulfilling need they want. Now, of course, there needs to be security mechanism, but we also have to consider that there needs to be a way to communicate with a database. And there comes the types of database according to which we have the different communication mechanisms and storing mechanisms through which we can categorize different databases. Now, two most popular databases are SQL databases that supports the SQL language, and SQL is nothing but a sequential query language. And second one is a NoSQL database. Now, at a glance, it seems like NoSQL is the database that does not support SQL language, but no. NoSQL means not only SQL. So it supports lot more things than only SQL. I mean, they did not use much thought regarding naming the type of database, but overall, this is a really popular and very powerful type of database. Now, there are few more databases that we are not going to talk in this video, but let me know in the comments if you want me to make a video on NoSQL, in-memory, time series, and distributed databases, because that is also a really interesting topic. So first let's understand that what is an SQL. So SQL is nothing but a structured query language, and in a structured query language, it was designed by IBM sometime in 70s. It was a way for the data tables to communicate with each other and users to communicate with the databases basically. So you can typically use it for relational database management. Now what is relational database management means? Any particular scenario or any particular application that deals with the relationship of different data entities. So if you think of like a person table, or if you think of a scenario of a school. Okay, so in the school we are going to have many entities. We are going to have like one table for subjects, we are going to have one table for students, we are going to have one table for teachers. And all of these tables, of course, they're unique in their own because they have their own information, but they from time to time they also needs to communicate with each other and work in tandem with each other. Because if you want to know, or if I as a user wants to know that how many students are enrolled for maths in grade 7, so for that I need to go to grade 7 table, maybe I need to go to students table, I need to go to subject table, and then I need to do some connections and find the meaning, which means this is a great example of a relational database system. And for that SQL would be a great option basically. So data is typically stored in various tables, and it is a very easy to use and very powerful mechanism. As I mentioned that it was originally developed in 70s, but still it is working like a charm. So that's a great advantage to have. Now there are a lot of things we can do with the SQL, and these are some of the common commands. Like you can create table, you can select values from the table, you can insert the values into the table, you can update any existing records in the table, and then you can delete those records as well. So these are just trivial matters. I'm not going to go much deeper into the realm of SQL, because that in itself an entire topic that needs attention of maybe a couple of hours. So I'm not going to do that. These are just the common commands. If you want to take a look, you can take a look. Basically you are dealing with just table and columns and rows, but you see there is one important thing in these commands, that for every single column that you define, you need to define what type of data type there is going to be in those columns, which means you are strictly bounding those columns to only add data of that nature. So in the first name, or let's say that you have people's table, in the first name you only wants to have names. You don't want to have some odd characters like star or hash or maybe some digits. So you can actually restrict that in SQL quite easily. And next topic is SQL joins. So I just mentioned that different table needs to communicate with each other with the example of school, where student table and teacher table and class table and maybe classroom table, whatnot, they all might need to communicate with each other. And many times you need a lot of information from one table and maybe just a few set of information from the other table. So there SQL has a very good mechanism called SQL joins to communicate with each other, or for various tables to communicate with each other, and you can select what portion of value you want from those tables. So these are 4 examples of the joins: left join, right join, inner join, and full join. And depending on this Venn diagram, you can understand that whichever command you use, you can get those particular types of values. These are some of the examples of join commands. Now let's move forward to our main topic, that is SQL databases. So what are the total databases available to us? Basically is any database that deals with the SQL language or that operates on the sequential query language is defined as SQL database. This database is typically tend to be relational database that can handle SQL, and of course it can do all the operations with the data. On top of it, there are some important characteristics we will have to understand for any SQL databases. Number one, it operates on the tables. That is one of the most important properties of SQL database. So whenever you see a relational setting where tables can be used, then think of using SQL databases. Next thing is we have a well-defined schema. Now in the previous example, I mentioned that for the first person, you can control that in the first person column, you only wants to add string like data character, nothing more than that. And that can be considered as one of the schema of the data. So in the SQL, you can completely define how each column is going to look like, or how each row is going to look like in any particular table. And you can find those, or you can define those entries, and you can enforce those entries for all the incoming data inputs. On top of it, it operates on the SQL language, so that is a given fact. Now, data integrity is a really important topic, and it is well maintained in SQL database. So what does data integrity means? Data is going to remain what you entered. If you make change to one data table, it is always going to reflect in whenever you try to retrieve it. Let's say you are dealing with in a replicated scenario and you have one table that has been updated and the other duplicated table has not been updated. It should be updated before you can retrieve the other data. So data integrity and consistency is very important for SQL databases. Now it also supports complex transactions. And what do I mean by complex transactions? Think of a scenario where I am a client of one bank, bank A, and my wife is a client of another bank, bank B. Now I want to send money from my account to my wife's account. So what should be the whole transaction flow is going to look like? Well, first of all, I'm going to request that I need to send money from this account to another account. In that scenario, I will provide that how much money I'm transferring. Let's say that the amount is $100. Now for that $100, money needs to be deducted from my account. That is number one. So now my balance is $100 less. Now this bank needs to communicate with the other bank. For the other bank, they need to find the account for my wife. Once they find the account for my wife, they need to deposit $100. Once the deposit has been done, then only we can conclude that the entire transaction has been completed and we can mark it as a successful transaction. Now, if anything happens in between, let's say that money got deducted from my account, but for some reason, the bank was not able to communicate with the other bank and money never reached to my wife's account. What needs to happen in that scenario? I would expect that money should be put in back to my account. If not, then there is a loss of monetary. So this is an example of what a complex transaction looks like. And whenever you are dealing with complex transactions, think of using SQL databases because they are really good at handling these kinds of complex, long running transactions. And there is also one more problem with SQL databases, that they are difficult to scale horizontally. What do I mean by horizontal scaling is that it's very difficult to maybe shard data horizontally or create like replicated entries, because if you have replicated entries, if you want to make change to one set of database, you will also have to make the change to the second set of database as well. And that can be tricky. So typically they are vertically scalable, where you increase the capacity or size of an existing database rather than creating multiple copies of the same databases to basically perform or do more operations. So that is also an important point to remember. And next, it is ACID compliant. So question is, what does ACID mean? It's not the acid that we all think that you are thinking. No, it's not like that. ACID is actually a very important term that is defined as atomicity, consistency, isolation, and durability. What ACID simply means is that every single transaction is atomic in nature. It is going to remain consistent, which means going back to our example of money transferring from one account to another account. Either once the money has been updated in my wife's account, then money has been deducted. Consistency is always going to be there. And after that, no matter how many times I check, the balance is going to remain the same. There won't be any scenario where behind the scenes for a bank's database, one of the database contains the new balance and the other database contains the old balance. No, all the database in the bank server are going to contain the same data, and that is called consistency. Next one is isolation. So each transaction is isolated in nature from one another. And durability. Durability means whether the transaction is going to complete fully or it's not going to complete at all, which means if money has been deducted from my account, it has to enter to my wife's account, and then only we can conclude it to be completed transactions. If it breaks somewhere in between, then the whole transaction would collapse and money would be returned back to my account, which means either it's 100% successful or it's none. So that is a really important property to have, and this is very useful because it guarantees data integrity and consistency. So I just explained what does that mean. And this ACID property or ACID compliant system, you need to use it whenever the reliability of data is the most important topic. So there are many applications you can think of it. Think of any scenario like e-commerce website. So if you order something from Amazon and money has been deducted, you need the product to be delivered, and your order should only be placed if the inventory has that particular item. If it does not have, it should not have gone through. Banking transactions or value, money you are depositing into your account, money you are transferring from one account to another account. Think of like complex transfers, like maybe an account in India to an account in America, and then now it becomes a gigantically complex transactions that needs to deal with lot of different entities and lot of different databases. So all of those things needs to be ACID compliant. Now same way, healthcare, payment system, government documents, government updates, anything that you can think of that deals with sensitive amount of data that needs to remain constant. In all of those things, you want to have ACID compliant values and ACID compliant properties, like mission critical systems, multi-user environments, or complex transactions, long running transactions. All of these scenarios has to be ACID compliant. If they are not, then the systems would start breaking up, and that is going to be a very bad experience for the user. Now with the ACID, it has a lot of good things. It has a lot of like security, guarantee, integrity, consistency and whatnot, but it comes at a cost. You will have to wait for it. It is not very fast. There is the latency issue. So it is definitely very secure and very reliable, but if you are dealing with, like, if you want to have a high latency system where ACID is not that important, in that scenario, try to get something else. But if the security is more important, always go for ACID compliant systems. And that brings us to the next. Now let's see that what are the different examples of SQL databases, some of the popular databases, and these are battle tested, very well developed and available systems like MySQL, Postgres, Oracle, SQLite, Microsoft SQL Server, and all of them, they all have their own cloud components as well. So for cloud, we would have Azure MySQL Server or something like that. So you can think of it like you would be able to find all the databases. Now comes the most important topic. Under what scenarios you are going to decide that, hey, I need to choose an SQL database. Now I gave a lot of information in this video so far, like explaining what SQL databases are. But typically, whenever you are dealing with a relational data, so whenever you have a data that can be stored in a table and that has a relationship with each other, and then you might need to process on those things, think of using SQL database. Next is, this can only operate on the structured data. So structured data, we all know that data can be stored in tables very nicely, that can have well-defined schemas, and you have a proper structure for that data. So whenever you are dealing with structured data, you can think of choosing SQL database. ACID property compliance, whenever a transactions needs to be ACID compliant, always use SQL data, nothing else. And same goes with the consistency. So because in this ACID, C actually refers for consistency, so you can already think of it like whenever you're dealing with high consistency situation, you need to use SQL. In same way, if you want to have the utmost data integrity through various constraints on the data, you can also think of using the SQL databases. So this concludes the very good guide on what SQL databases are and when to use it. Now comes the another important part, that is NoSQL databases. So I know NoSQL, not only SQL data, because it is much more than that. It is a very complex system, and this is typically designed to store and handle large volumes of unstructured or semi-structured data. And now I'm not saying that structured data cannot be handled through SQL through NoSQL database. Of course, structured data can also be handled in a relatively efficient manner, but whenever you are dealing, NoSQL data shines with unstructured and semi-structured data, because this is specifically what this has been created for. So always think, whenever you see unstructured or semi-structured data, think of using NoSQL. Now we all know what unstructured and semi-structured means. Unstructured means any such like kind of like audio, video, or those images kind of files, or maybe entire text documents and stuff like that, that you don't have a well-defined schema for, and that can change very quickly. Semi-structured, XML files, JSON files, log files, different entities, different incoming data. So these two are typically very popular for NoSQL databases. And whenever you need to deal with flexibility, scalability, and high availability, always think of using NoSQL databases. Why flexibility, scalability, and high availability? Well, think about it, because typically whenever you are dealing with any system, think of an unstructured data format or semi-structured data format. Are you going to encounter two same audio files twice? No, right? You are going to always be dealing with lots of amount of unpredictable data that does not have any constraints of data schema like we have in SQL, because in SQL, if you know the first name is there, it has to be a string value, but in NoSQL it can be anything and it can change so frequently. Let's say that you are dealing with a text like document and you want to store that into the database. Now the content of that text document is going to continuously change. For any particular 2 pages there would be a lot of different values, so you can't predict that what type of schema is going to be. So you need to make sure that flexibility is there. Next, scalability, because you are dealing with large volumes of data and you are trying to process it efficiently. So scalability needs to be handled. And next one is high availability, because whenever you are designing a system, you want it to be available all the time. And NoSQL are fully used in all the applications we use today, no matter how small, big, or whether it's your digital dishwasher or whether it's your computer or keyboard or maybe your Roomba or your IoT device, they all are using NoSQL data and they are all processing millions and millions of gigabytes of NoSQL data every single minute of every single day. So it can be anything and it is very useful in many different scenarios. Now, important thing is NoSQL database they are not ACID compliant. So whenever you have to deal with ACID compliant structures, NoSQL is basically not a good choice. Like they try to implement ACID, but it's not very good. So always whenever you need to use ACID properties, think of going for SQL unless you can think of a NoSQL. Now let's see that what are the different database types NoSQL database have. So first one is something called a key value store. Now we all know what key value databases are. Key value databases are where one value is defined as a key that is typically indexed, or you can very quickly find it. And through that key, you can associate a lot of different values behind that key. And whenever you want to basically find those values, all you need to do is search using that key and you can pretty quickly find that data. Next one is a document database. So as the name suggests, it's very good for storing or handling different types of documents and handling them. Next one is a graph database. This is one of my favorite databases because I personally like graph-based data structures, but these have real popular real life applications. And the last one is wide column-based databases. Now let's first start understanding the key value stores. So key value stores is nothing but a collection of key value pairs, and you can store any kind of information in that. They are typically very simple to implement, and just like they are very similar to hash map, but for large volumes of data. Now think of Amazon inventory system. Now inside the Amazon inventory, it is not a very good system to implement using a SQL database. Why? Because all the values that are currently placed in Amazon's inventory, there are millions of items and they all have different attributes, which means we are dealing with flexible schema. Because if we are talking about an item like a t-shirt on Amazon inventory, then t-shirt has attributes like color, size, maybe what type of material. But if we talk about another item on Amazon's inventory like a fridge, so fridge has an entirely different set of attributes. Things like maybe what is the size, how much electricity consumption does it do, or what type of material has it been made of, maybe stainless steel or something like that. So in that scenario, of course, SQL would not be a very good choice. But in NoSQL, you want to have an information where depending on the key value pair, you can find all of those attributes quite quickly. So in this case, key would be the product ID and value would be all the attributes associated with that product. So that this can be a very good example for key value transactions. Like and some of the popular examples for key value stores that we currently have is Redis Cache, because Redis Cache is really good and it mostly operates on the key value data storage mechanism. And second one is Amazon DynamoDB. Both are really good, very well battle tested NoSQL key value pair type of databases. So if you want to learn more about them, you are free to search about them. Now next one is document databases. So document databases, as name suggests, it stores data in a flexible semi-structured documents, and these can be things like JSON files, XML files, or log files, or other document basically files which can update or change quite frequently. Now you are mostly dealing with flexible schema, and you are dealing with a lot of content that you need to manage through these document type of databases. So think of it like files or logs or etc, all of those kinds of systems. Maybe like if you have a website that deals with or that manages blogs for all the different people, now all the information in the blogs are consistently going to change. So in that case, you can think of, to store those information, you can think of using document databases. And some of the popular document databases are MongoDB and Couchbase. These two are really popular, and it's always very good to learn about them. Now next one is wide column databases. Now wide column databases organize all the data in the wide columns rather than separate rows, and it is very good to deal with large volumes of data sets. So whenever you are dealing with large volumes of data that does not need to be ACID compliant, or that is unstructured or semi-structured, always think of using wide column databases. They are very commonly used with like time series database, and they are very popular for analytics or building large language models or large data models, and doing some information or doing some curation on the existing data. Some of the examples for a wide column databases are Cassandra and Apache HBase. Both are really popular. Both have been used for quite some time in the industry, and they are both excellent at dealing with large volumes of data, doing real-time analysis, making all the changes. But of course, they are not very good with basically ACID properties or any of that kind of information. They are mostly there for handling large volumes of data. And that brings us to the last value, that is graph databases. So in the graph databases, it is very similar to graph data structure, where all the entities are treated as nodes inside the graph, and then they are connected with other nodes through some edges. And that explains many different relationships and many different connection points between any two entities. So think of it like data as nodes and edges, and it is very good for efficient querying on complex relationship. So think of the scenario of maybe like an entire city where you have different data points and you want to connect all of them. Maybe graph databases can be a good approach. Maybe think of a scenario of any particular website or application like LinkedIn, Facebook, Twitter, where you have these complex relationships between people, where one is following another is not following the other person. Then there is 3 persons are following the same person, maybe a million people are following one, and that person is not following anyone. All of these scenarios are very popular for graph-like databases. Like you can think of using graph databases in this scenario, and they are ideal choice for whenever you are dealing with complex networks. Not only like, of course, social networks, it's really good, but whenever you are dealing with complex networks, search engines, recommendation engines, analysis, so all of these scenarios, think of using a graph database. And some of the popular graph database that we currently have is Neo4j and Infinite Graph. Both are really good. I have tried Neo4j, but Infinite Graph I was also able to research that it is also a good approach. And now let's talk about that what type of schema is there in NoSQL. Well, actually NoSQL is very flexible when it comes to data schema or enforcing data schema. Basically it's very random. You can change more things in the real-time manner frequently without worrying so much, unlike SQL, where the schema tend to be quite rigid and needs to be enforced completely. Now on top of it, because it is very fragile, it is very useful whenever you are dealing with agile situation or dynamic situation, where the incoming data is continuously changing, or data storage can be anything, or it is quite random, unpredictable, dynamic in nature or whatnot. All of these scenarios, NoSQL provides great tools for you to store that kind of databases. And it is very good wherever the data needs to be hierarchical or nested as well, because that also is not very easy to implement in SQL databases. So NoSQL database has a lot of advantage in that regard as well. Now, whenever you need to write a query inside the NoSQL database, well, depending on the database, the query language changes. So SQL tend to have very similar query language, but query language in NoSQL is very different depending on what type of tool you are using, what type of data language you are choosing. And have the access to basically do all sorts of operations with the database, and the type of database you are using is going to change the type of query language that you are going to have. And now the important topic comes in: under what scenarios should you consider thinking of choosing a NoSQL database over SQL database? So very first thing is, whenever you're dealing with unstructured or semi-structured data, for sure go with the NoSQL database. You are dealing with a situation where the schema might be flexible, or you don't have too many relationships. All the values are maybe isolated in nature, dynamic in nature. A rapid change is there for the incoming data. You cannot predict that. So under those scenarios, NoSQL is a great idea. Now, NoSQL try to implement ACID, but it does not do very good job of it. So whenever you are dealing with a non-ACID compliant situation, always then only use the NoSQL database. And NoSQL is great for high throughput and scalability. So you can process millions of transactions very easily and very frequently, because it does not deal with so much of this ACID property that was the bane for causing the performance issues in the SQL. So you don't have that in the NoSQL database. And this tends to be in the distributed nature. It is also highly available system. So whenever you have these types of requirements, think of choosing NoSQL databases, because overall this is going to be much better approach. And more than not, like, NoSQL tends to be cheaper than SQL database as well. So that is also a good thing to know. And whenever you are doing some real-time analysis, dynamic changes, or graph-like models you are dealing with, then also NoSQL is a great choice. Now here I have noted down some differences between SQL and NoSQL databases. Let's just quickly go over them. This is just the entire conclusion of all the things we were speaking about throughout this video. So first, SQL, if we talk about how the data is being stored, it is typically we are dealing with structured data and a well-defined schema. But NoSQL, we are dealing with unstructured or semi-structured data, and typically the schema is not going to be very well defined. Now, SQL is ACID compliant, NoSQL is not ACID compliant. We can do a lot of different transactions in SQL. Same type of transactions we can do in NoSQL as well, but the language differs depending on the type of database you are using. In the SQL, data relationships tend to be very well defined, but in the NoSQL, we have explicit support for the relationships, but in most cases we don't deal that much with the relationships, except the graph type of NoSQL database. And speaking about scalability, SQL databases are not very good with horizontal scaling. So if you want to put more and more data, you essentially needs to have bigger and bigger size of your database. So you need to go in the vertical scaling phase, but in NoSQL you can do horizontal scaling, and that is very powerful, very good. Schema flexibility is not there in SQL. In the NoSQL, there is dynamic schema, schema-lex, flexible schema, evolving schema. Put whatever your names you want to put. You have the ability to do all of those things. And in terms of real-time analysis, it is not really good. Like, SQL has something called OLAP, Object Language Analytics Protocol, something, but that too is not very good. I mean, it does that job, but not very not in a very nice manner. But NoSQL really shines over here. It is very good for real-time data analytics. So if you have large models, or if you are processing a lot of millions of transactions and you want to find the real-time analysis meaning from them, maybe a system like financial management system, all of those things, NoSQL is really good in that regard. And whenever we are dealing with the complexity of the data, then typically SQL databases are going to have structured data with strong integrity constraint, and NoSQL is completely opposite to it, lower level of complexity. SQL database is really good whenever you are doing complex transactions like business application, or where data consistency is very good and very paramount and the data is structured. Then try to think of using SQL database. But if you want to do a lot of real-time management or content management, unstructured data, semi-structured data, Internet of Things, real-time analytics, dynamic changing schema, documents, images, media, file, all of those things, think of using NoSQL databases. And that brings us to the cost, that SQL tends to be more expensive than NoSQL. So that's why whenever you are designing your system, if you can, try to use NoSQL databases, because that is going to end up saving your cost. But you will have to be very careful when choosing NoSQL databases, because when you are dealing with more constrained data, in that scenario you always needs to go with SQL database. So that was my explanation on SQL versus NoSQL. Let me know in the comments if you want to see all the other data types, and I know this video might have bored you to the death, so I'm sorry for that. Let me know in the comments if there is anything else I could have done to improve this video. Anyways, thank you so much. Take care.